So whilst we're talking about linear function, finding the equation of the lines, the point slope formula, of course, allows us to find the equation of any line, provided we have two pieces of information, as the name suggests, a point and a slope. When you look at it, really all it is a slope formula that's been rewritten. And slope, of course, is y minus y1 over x minus x1 multiplied by the denominator, bang. There's the formula. So we got this question where we've got to find a line passing through 2 points, and I suppose the thought process is, oh yeah, okay, I've got to find a line, that's not a problem. All I need is a point and a slope. I have a point, excellent. Slope, oh, damn. Oh, but that's okay, I've got a formula that allows me to find slope. So let's do that first. So the first thing we do is find the slope between the 2 points. Turns out to be -2. I now have a point and a slope. Choice of the points, doesn't matter which, of course, because they're both on the line. So y minus y1 equals m outside of x minus x1. And I put it in general form, so there it is, 2x plus y plus 2 equals 0. Now, this sort of question, find the equation line passing through the point and is parallel to 3x plus 4y minus 5. So I need two pieces of information. I need a point, I've got that, 2, -3. Slope, damn, haven't got a slope. But of course they've provided me with more information which will allow me to find the slope. And that is that it's parallel to 3x plus 4y minus 5. So if I find the slope of this line, which turns out to be -3/4, once I put it into mx plus b form, and it's parallel, and we know parallel lines have the same slope, so the slope I want is -3/4. I have a point, I have a slope, and point slope formula, away we go. Have a look at the answer. Have a look at the question. What do you notice about the line it's parallel to and the answer?
Given by a constant.
Yes, you could say it that way. Differs by a constant. I was going to say the coefficients of x and y are the same, but I mean, that is the same thing. And of course it is, because if they're parallel, if I was going to rewrite them into y equals mx plus b, I've got to come up with the same slope. So if I know that piece of information, I can do this question a lot quicker. Because if I know it's parallel to 3x plus 4y minus 5 equals 0, then I could say, well, I know the answer must be 3x plus 4y plus some constant number is equal to 0. I know it goes through the point 2 minus 3, so I can sub in 2 minus 3 to work out what that constant is, and there it is, sure enough, it turns out to be 6, and I've got my answer. So 3x plus 4y plus 6 is equal to 0. So that's an alternative way you could, of course, approach that question. The similar sort of question when they're talking about perpendicular. Okay, so I guess the original idea is to say, well, I've got a point, I need a slope. It's perpendicular to this line. Well, that line, we now know which slope's 9 on 4 when we put it into y equals mx plus b form. I want the negative inverse because it's perpendicular. So the required slope that I want is -4/9. Put it into the point slope formula, and there we go. But again, compare the answer with what it was perpendicular to, and what do you notice this time? Yeah, the coefficients have swapped, so it was 9x, it's now 9y, it was 4y, it's now 4x. But the other, of course, important thing is the sign in between the x and the y has changed as well. So if we know that, okay, I'll just swap the coefficients, change the sign in the middle of them. Again, I can save myself some time. So I could look at this question and say, well, all right, it's 9x minus 4y plus 6. It's perpendicular to that. So therefore, my answer must be 4x plus 9y plus some constant equals 0. I know it passes through the point 6,4. So sub it in. I can work out my constant. There it is, -60. Therefore, there's the equation of my line. So that idea works for both the parallel and the perpendicular type of question. Now, we talked about proving 3 points were collinear. That's when, of course, 3 points lie on the same line. Well, we have a similar thing when 3 lines go through the same point, and we call that concurrent. So how do I prove these 3 lines are indeed concurrent? So the way I would approach it, well, I want to find their point of intersection. So I'd solve any pair. I've picked L and M. Solve L and M simultaneously If I then sub that answer into the third line, and it does indeed lie on that line, well then the third line must also go through that same point. So if it does satisfy, then that would be proof that they are concurrent. Okay. So 5D.